In this lesson, you will learn how to solve a linear system of equations using the substitution method. Remember that the solution to a system of equations is the ordered pair that satisfies both equations. Remember that an ordered pair is a point on the coordinate plane x, y. In the previous lesson, we learned how to solve a system of equations by graphing. If we had a grid, you could graph this system of equations, and the intersection point would be the solution. So the solution to this system of equations is 1, 3. If we were going to solve the system without a graph, solve it algebraically, one of the methods you could use is the substitution method. This method is useful when when one of the equations or both of the equations is already solved for a variable or easily solved for a variable. So to solve this system algebraically, your first step would be to solve one of the two equations for a variable. If you look, the second equation is already solved for y. The substitution method says that when you're trying to solve an equation, we're looking for the point where the two x's are the same and the two y's are the same. So if we were going to do this algebraically, if this y equals x plus 2, then so does this y. And we can substitute or replace the y in the first equation with what it equals from the second. So to do the substitution, we're going to take the answer from step 1, x plus 2, and we're going to replace it in that first equation. So we will have x plus and then instead of the letter y, we're going to replace it with x plus 2 and set it equal to 4. Okay, so all we did was replace the letter y with x plus 2. Now you've got an equation that you can solve for one variable. So to solve this equation now, we have nothing to distribute in front, so we can just drop our parentheses. To end up with x plus 2 equals 4. We can then combine like terms. X plus x equals 2x to have 2x plus 2 equals 4. Now you've got a two-step that you can solve. And draw our dividing line down the equal sign. And everybody knows how to solve a two-step equation. We're going to subtract 2 from both sides. And we're left with 2x equals 2. Divide both sides by 2. And our final solution for this part of our equation is x equals 1. you now have half of your answer, because remember, the solution to a system is an ordered pair. So we solved the equation and we got the first half of our answer, x equals 1. We can now take that 1 and put it back into y equals x plus 2 and replace the letter x with the 1 to easily get our answer for y, which is 3. So our x equals 1, our y equals 3, and our solution is 1, 3. In example number 2, look at the two equations. Step 1 says to solve an equation for a variable. The first equation is already solved for a variable. It says x equals 2y minus 5. So I'm going to put a box around 2y minus 5. Find the matching variable in the second equation. So we're going to replace the x in the second equation with what it equaled from the first one, 2y minus 5. So I'm going to rewrite that second equation. Instead of the letter x, I'm going to put parentheses, put 2y minus 5. And that equals 1. Step 3 is to solve the equation. I have y, and then in front of the parentheses, I have the number -1. So I need to distribute with multiplication that -1. -1 times 2y is -2y. -1 times -5 is +5. And that equals 1. Now we can combine our like terms. Y minus 2y. In your calculators, you can put 1 minus 2. Gives you -y plus 5 equals 1. Or -1y plus 5 equals 1. I've got a two-step. I'm going to subtract 5 from each side. -1y equals -4. I divide both sides by -1, and y equals 4. So now I have half of my solution, y equals 4. I can move on to step 4, which says substitute. I'm going to take this 4 and I'm going to put it back into the original equation that I solved. I'm going to put it back into the box. Because if this y equals 4, then all of the y's equal 4. So I can find x easily by putting 4 in for y in that first equation. 2 times 4 is 8. And 8 minus 5 is 3. So x equals 3. I now have the solution. If these two equations were graphed on a coordinate plane, they would cross at the point 3, 4. Your final answer is always written as an ordered pair. In example number 3, step 1, solve an equation for a variable. The first equation is solved for y. So I know that I'm going to substitute y in the second equation. Okay, it's always the matching variable. In the first equation, it says y equals 3x minus 3. So I'm going to put a box around that. And now I'm ready to substitute. I'm going to rewrite that second equation. But instead of the letter y, I'm going to have 3x minus 3. Notice how I wrote the entire equation, the entire second equation, and I left a space where the y was with parentheses around it. Then I'm going back to fill in 3x minus 3. This will keep you from dropping pieces of your equation. Okay. Now we're ready to solve. 2x. I'm going to distribute negative 5. Negative 5 times 3x is negative 15x. Negative 5 times negative 3 is positive 15. And that equals negative 11. I can now combine my like terms. 2x minus 15x, put it in the calculator. 2 minus 15. It'll give you negative 13x plus 15 equals negative 11. You now have a two-step you can solve. Subtract 15. These cancel out. Negative 13x is what you have left on the left. Negative 11 minus 15, put that in the calculator. You get negative 26. Divide both sides by negative 13. X equals positive 2. You can now take that 2 and put it back in the box from your original equation to solve for y. Y equals 3 times 2 minus 3. 3 times 2 is 6. So I have 6 minus 3. And 6 minus 3 is 3. So y equals 3. X equals 2. Y equals 3. Your final solution is 2, 3. On the back of your note sheet, try the following you-try problems. The answers are on the bottom of the screen, so make sure that you can match your answers to the ones that you were given.